Okay, this is Mr. Anderson from Kellogg Community College. I'm going to do some sample problems from section 7.2 and also section 7.3. In section 7.2, the factoring chapter, we're going to be working with problems numbers 59 and 63. And also in section 7.3, another factoring part of the chapter, we're going to work with problem 85. Okay, the first thing we're going to do is look at problem number 59. Problem number 59 is x to the fourth minus 3x cubed minus 10x squared. And our first job is to factor this. Now, the first rule of factoring is you look for a common factor, a greatest common factor, between x to the fourth, negative 3x cubed, and negative 10x squared. There's no constant to pull out except for a 1, which doesn't do us any good, but you'll notice that there is a common power of x we can remove, which is the lowest power of all of them, x squared. What this is going to do, 4 minus 2 is going to give us x to the second power, 3 minus 2, x to the first power, and then 2 minus 2, which is x to the 0 power, which is 1. 1 times negative 10 is negative 10. And there is this problem, which is factorable. Now, we look to see if there's a 1 in front of the x, which there isn't, so this becomes a short form factoring, which means that we look for two numbers to multiply to make negative 10 and add to make negative 3. Now, to help, I list out my terms that would multiply to make negative 10, and we're going to find that only one of these multiplies to make negative 3. So which two numbers add up to negative 3? It's going to be the bottom one. Negative 5 and 2 add up to me negative 3. So I now create from my x squared, I have my two x's here, and here are my n terms, which is our O and my I cable. My L cable will make negative 10, and then the O and the I cables make negative 3 if you're using FOIL. And don't forget to put what you factored out in front of the problem at the answer, because that will make a difference when you look at this on the graph in later sections. Now let's look at problem number 63. If we look at problem number 63, it's going to be a little bit trickier because it's going to have a lot more stuff in it. 15xy squared plus 45xy minus 60x. Now we have to look to see first if we, just like in this problem, do we have a common factor we can divide? Well, now we actually can take the 15, because each of these is divisible by 15, so I can pull a 15 out of each of this, each part of the trinomial here. I also notice that there's an x in each of these, so I'm going to factor out an x as well. So 15xy squared divided by 15x is just y squared. 45 divided by 15 is 3. The x is brought out and the y is inside. Negative 16 divided by 15 is negative 4, and the x is brought out. So now, in kind of a weird twist, we're going to factor problems with variable y instead of x. Well, take a look to see when we start factoring this trinomial, see if this is a 1, which it is. And therefore, we have to just take a look at the end and say what two numbers multiply to make negative 4 and add to make 3. So take a look at this combination. Which one of these three multiply to make 4 and add to make 3? Negative 4, I should say. Right, it's this one. These two numbers multiply to make negative 4 and add to make a positive 3. So I'm going to bring the 15x out to the front. I didn't forget it this time, just brought it right down. And my y squared is going to give me my y and y. And then we're going to then take a look here and put my minus 1 and my plus 4. All right, now that's the short form factoring, and now we're going to get into something pretty big and scary here. This is problem number 83 in section 7.3. Number 85, I should, right there. All right, now this is kind of a monster problem here, 12a squared b. My b's are going to look like that so they don't look like 6's, even though they probably will. 46ab squared plus 14b cubed. Okay, so the first thing I'm going to do is look to see if there's anything I can divide each of this to make it smaller. Well, one of the first things I can divide to make it smaller is a 2. Now, I've done actually some work before I did this problem to make sure there weren't any bigger numbers like 2, 4, 6, but the 14 really limits us because this can only be divided by 2 and 7. So since 7 doesn't work with 12, 2 is my only common factor. You'll also notice that there's a b squared, and a b cubed. So I'm going to pull out a b. And what this gives me is a smaller trinomial, 6a squared, no b term, minus 23ab plus 7b squared. Okay, now, we haven't really spent a ton of time talking about a situation when you have a squareds and b squareds inside the same problem. When you factor this, this is going to give us, I'm going down to the answer here to show you that the a squared is going to give you an a and an a here. The b squared is going to give you a b and a b here. Now, here's why this is a trickier factoring problem, is because this number is not a 1. So I can't just look for two numbers to multiply to make 7 and add to make negative 23. Besides, there are none. So what I have to do is now look at combinations. 1 and 6, my fault, and then 2 and 3. These are factors that multiply to make 6. Over here, this is 1 and 7. Now these have to be negative because of the negative 23 in the middle. So I got to find the right combination between these numbers on the left and these numbers on the right to make a negative 23. Now I'll show you the kind of guessing and checking you'll have to do, and I'm going to show you one that will not work. Let me pick incorrectly. I'm going to pick the 1 and the 6. So 1 and 6 is going to be multiplied by the negative 1 and the negative 7. Now in my head I can go 1 times negative 1, which is negative 1, and 6 times negative 7, which is negative 42. Well, negative 42 and negative 1 make negative 43. That doesn't make negative 23. But here is the correct combo that does work. 2 and 3, and the only choice, negative 1 and 7. Now watch how I position this. I'm going to put my 2 and 3 here. Now I can put my negative 1 and negative 7 in any order. I could put the negative 7 here and the negative 1 here. If I do, I'd get a negative 14 and a negative 3, which wouldn't make negative 23. But this is the right combo. There we go. So that combo, 2 times negative 1 is negative 2, and 3 times negative 7 is negative 21, negative 2 and negative 21. It works, negative 23. So now we go down here. We go down to my answer. We found that 2 and 3 worked for my 6, so I'm going to put the 2 there and the 3 there. That really doesn't matter, but then this really matters. The 2 has to be multiplied by the negative 1. If I put it in here, it will get added or subtracted, so I'm going to put the negative 1 over here. Notice I didn't write the 1. 1b is the same thing as 1. Now 3 has to be multiplied by negative 7. This is going to be negative 7 right there. And that is your final factored answer. Phew! Told you it was going to be a toughie. Well, thanks a lot, everybody. And take a look at more videos on my website, Mr. Math Anderson.